Hello, it's Brian. We're going to build a population in StatPowers today, and it's going to have some discrete and categorical variables in it that are dependent on each other. And so we're going to look at making these dependent distributions. So we're going to be looking at cat eye color and deafness in white cats. Coming from this example from Open Intro Biostatistics lab cat genetics. So very briefly, we have the gene that controls cat white coat color, KIT, is known to be responsible for multiple phenotypes such as deafness and blue eye color. A dominant allele W at one location in that gene has complete penetrance for white coat color. So if it has that gene, the cat will be white. However, it doesn't have complete penetrance on blue eyes and deafness. So here's we're going to be looking at a population of cats, and I'm going to just really talk it through as we're building this population. So this is a population of white cats, and we're building two variables. The first is going to be number of blue eyes, and that's going to be a discrete variable because they have 0, 1, or 2 blue eyes. And the second is going to be their hearing. They're either deaf or they're hearing. And I'm going to make hearing dependent on the number of blue eyes. So first off, the number of blue eyes, we're told that, first off, I want to make this a custom distribution with 3 possible values. We have either 0, 1, or 2 blue eyes. And I'm going to change the number of the probabilities are given. I'm going to clear these, and we're told that 30% of white cats have 1 blue eye. So I'm going to put that in first, 0.30 for 1 blue eye. 10% of white cats have 2 blue eyes. That's here. That's 0.10. And then lastly, the remaining 60% have no blue eyes. Now, we're also told that for hearing, it depends on the number of blue eyes. I'm going to add a condition because we're told that 73% of cats with 2 blue eyes are deaf. So first off, let's create the 2 values. They're either hearing or they are deaf, and we're going to create the first condition, discrete dependency condition 1, where the number of eyes is 2. The number of blue eyes is 2. The probability that the cat is deaf is 73%, with the remaining 27% hearing. I'm going to add another condition because we're also told that 40% of cats with 1 blue eye are deaf. So I'm going to create another condition where the number of blue eyes is 1, and the probability of hearing is 60. The probability of being deaf is 40. And last, we have the default probabilities, which really are for cats with no blue eyes. And it says that 19% of cats with other no blue eyes are deaf. So 19%. Of course, the remaining 81% are going to be hearing. So this is how we've set up these conditional probability distributions. We have a default distribution that's for the cats with no blue eyes. Then we have the condition 1 for 2 blue eyes. Condition 2 is 1 blue eye. You can cycle through those by going up and down in that list. So we have the population set up, and let's just do a sample and just test it out. And it looks good. We have cats with a bunch of different numbers of blue eyes. I'm actually going to test it out, let's sample 300 of these cats, and let's copy this data and bring it into 2 variable analysis just to double check and make sure it all looks good. So I'm going to open in a new tab the qualitative 2 variable analysis, where I'm going to paste in with the 2 variables we have blue eyes and hearing. I'm going to just paste in the data that I just created and calculate a contingency table, and I'm going to look at the marginal table. So I would expect for the proportions of So proportions of cats with 0 eyes, yeah, it comes out to be about 60% as I expected, with 1 blue eye 30% and 2 blue eyes about 10%. And we can look at the row proportions for the cats with 0 blue eyes. It turns out to be about 17% of them are deaf. With 1 blue eye, it comes out to 38%, which is about what we put in. And we have, for 2 blue eyes, 83%. Of course, there's a smaller sampling of cats with 2 blue eyes, and so that's a little farther off from what we set in the population parameters, but that's what you get with a small sample size. So this is how we could set up. Now I want to build onto this with another variable, and I'm going to go to the further. Okay, now we have further information that deaf white cats have an increased chance of being blind, but that the prevalence of blindness differs according to eye color. While deaf white cats with 2 blue eyes or 2 non-blue eyes have a probability of 20% of developing blindness, deaf and white cats with 1 blue eye have a probability of 0.4 of developing blindness. So I'm going to create a new variable that is blindness. And it's a categorical variable that is dependent on the number of on the hearing and the number of blue eyes. Okay, for blindness. Now we have two values, right? They're either seeing cats or they're blind. Now the default probability is 100% probability of being a seeing cat, but we have conditions. If it's a deaf cat with 2 blue eyes or 2 non-blue eyes, they have a 20% chance of developing blindness. So let's add that condition. Actually, we're going to have 2 conditions. If we have 0 blue eyes and deaf, then we have only a probability of 80% of being seeing and 20% chance of being blind. And I'm going to build that other condition, which is if they have 2 blue eyes and they are deaf, then we have the same 80% chance of being seeing and a 20% chance of being blind. And then we have another condition, which is if they have 1 blue eye, they have a 40% chance of developing blindness. 1 blue eye, deaf, we have a 60% chance of being seeing and a 40% chance of developing blindness. Now, actually, what I read now, white cats that are not deaf have a probability of 0.10 of developing blindness. That's regardless of the eye color. So let's go back to the default probabilities, and that's they have a probability 90 of being seeing and 10% chance of getting blindness. So let's sample again. Okay, we have all of this information now, and I can let's display this as a table. So you can see we've built this population with a pretty complicated dependency where the blindness is based on a dependency on 2 variables, hearing and the number of blue eyes. And we can answer a question like, well, based on this complicated genetic dependency, what proportion of white cats? If a cat is white, then what are the probabilities? What's the probability that it might develop blindness? Generally, regardless of knowing anything about its number of blue eyes or whether it is deaf or not. So so that's my example of a population with 2 dependent variables, and how it's well, it takes a little bit of work to build it, but it's nothing you can't do, right? And it's fairly straightforward, I would say. Okay, well, see you later. Bye.